Hello, people. Today we're going to be looking at some basic trigonometry, and that typically involves sine, cosine, tangent, or sine, cos, and tan, as they pertain to a right angle triangle. Now, using these basic trigonometric ratios, we can figure out, if we know two of either sides or angles, we can then go and figure out unknowns. Okay, so it's sort of like, whereas Pythagoras, we could take any two sides of a right angle triangle and figure out third side. Using sine, cosine, and tangent, we can find out angles and lengths on a right angle triangle. So let's have a look. Before we do this, we need to maybe define a few features of a right angle triangle. So we already know that the side that is opposite, so that is the side that's not touching the right angle, is called the hypotenuse. Okay, so we've learnt that one from an earlier video. What we need to do now is we need to define what in a right angle triangle we call an adjacent side. Okay, so an adjacent, okay, and the opposite sides. Okay, either of the two sides which are not the hypotenuse can either be adjacent or opposite depending on the angle we're looking at. Now, I know that sounds like some sort of lunacy, but let's just take this for example. So let's just say that we're looking at this angle here. So in the top left corner, one side is the hypotenuse, and that's this side. One side, which is part of the angle, we would call the adjacent side. Okay? The side which is opposite the angle, we would call the opposite. Okay, so what we're going to do is let's just back things off a little bit, and let's use some colors for this. So let's call this angle X. Okay, so for angle X, we have this side would be the adjacent, and that's because it's adjacent to the angle we're looking at, and this side would be the opposite because it is opposite the angle we're looking at. Now, let's just say, for example, we're looking at this angle, okay? And let's just call this angle Y. Now, the side which is adjacent to Y is actually this side. So now this side is the adjacent, and for angle Y, this side would be the opposite because it is opposite the angle, and this one is adjacent to the angle. So this one is opposite and this one is adjacent. Just like when looking at angle X, this side is opposite and this side is adjacent. The hypotenuse, sorry, let's just change the color back there. The hypotenuse is always opposite to the right angle. Okay, so hopefully that hasn't lost you too much. Now, we have very special ratios involved in a right angled triangle. And let's have a bit of a look at those now. So let's work in black. We have if we look at angle Y, okay, or angle X, we have, well, let's look at angle X to begin with. So we have sine X, probably do that, equals the opposite over the hypotenuse. So what that's saying is that the ratio of the opposite for x, so that's this one here, over the hypotenuse gives us sine x. Now just have to, it'll make more sense once we do an example. Cos x equals the adjacent side over or divided by the hypotenuse, and tan x equals the opposite over the adjacent. So that would be the opposite over the adjacent. Okay. And so too for y. So sine y would be the opposite, but in this case it would be this opposite over the hypotenuse. Hypotenuse is always the same. Cos y would be the adjacent, in this time this adjacent rather than this adjacent, over the hypotenuse, and tan y would be the opposite over the adjacent. Okay, so now that sounds like absolute gobbledygook. Okay, so there's a nice easy way to remember that, and the way we remember that is the mnemonic SOHCAHTOA. So we have so, ka, toa. Okay, and that stands for sine equals opposite over hypotenuse. Ka, cos equals adjacent over hypotenuse, and tan equals opposite over adjacent. So this is the basic trigonometric ratios as they apply to a right angled triangle. What we'll be doing is having a look at some examples in just a moment.